So today we're actually going to start a new unit and we're going to look at exponents. And in the lesson, we're going to look at a little bit of vocabulary and do a few examples. So to start off though, we need to be able to read what is in our bubble here, our circle. And we read this as 3 to the power of 4. And each component of that actually has a name. So the 4 we refer to as the exponent. The 3 is referred to as our base, and the whole thing is called a power. So 3 to the power of 4, the power is 3 to the power of 4, the exponent is 4, and the base is 3. And what does this actually indicate? Well, 3 to the power of 4, it's telling us how many times the base, in this case 3, is multiplied by itself. So here we can see that this 4 is referring to 3 times 3 multiplied by 3 multiplied by 3, 4 times in total. This is our expanded form. This we call our index form. And finally, when we simplify it completely and we get 81, this is just our simplified form. Alright, let's do a few. So our first example, we have a bracket and the negative 2 to the power of 4. So this exponent is affecting everything inside the brackets. Notice it's touching the brackets, and it's affecting everything inside of those brackets. So if I was to rewrite this in expanded form, I would have negative 2 multiplied by negative 2 multiplied by negative 2 multiplied by negative 2 4 times. So again, just for some vocabulary, this is expanded form. Okay, now if I want to simplify this, notice that I have a negative multiplied by a negative multiplied by a negative multiplied by another negative. So it's going to be a positive, and 2 times 2 times 2 times 2 is 16. So our simplified form is 16. Now in the next example for B, we have negative 2 to the power of 4. Now this 4, ask yourself, is it affecting the negative and the 2 or just the 2? And in fact, it's only affecting the 2. Notice that the 4 is only touching the 2. In the above case, in A, the 4 was affecting the entire thing because it was touching the brackets. So everything inside of those brackets were included. In B, there is no brackets. The 2 is separate, or sorry, the negative is separate from the 2, and therefore we actually write this as the negative stays, and it's 2 multiplied by 2 multiplied by 2 multiplied by 2. And in this case, there's only one negative symbol, and therefore our answer is negative, and 2 times 2 times 2 times 2 is equal to 16. So you really have to watch for the difference here. So make sure that you notice the difference. And the exponent is always only affecting what it's touching. Okay, that's the big hint there. Okay, so C, we can rewrite this as so with C, our exponent is 3. And it's touching the bracket, and therefore it's affecting everything inside of the bracket. So if I rewrite this in expanded form, I would have 3 over 4 multiplied by 3 over 4 multiplied by 3 over 4. And I can simplify this one more time. So I have 3 multiplied by 3 multiplied by 3 divided by 4 multiplied by 4 multiplied by 4, which is just 27 over 64. Now alternatively, what I could have done is I could have taken this and written it in index notation. And this means that instead of doing the expanded version, I would have simply written it as 3 to the third over 4 to the third. Notice that these two are saying exactly the same thing. Actually, these three are all saying the exact same thing. But the bottom one that I'm shading in green right now, it's a little bit easier to write. It takes less time, and we like to do things as fast as we can. So using index notation, it just kind of shortcuts your time. And again, 3 to the power of 3 is 27. 4 to the power of 3 is 64. And my solutions for both ways are exactly the same. Alright, let's do D. Now, I'm going to show you two ways with D. The first way, we love BEDMAS. It doesn't go away. So the first thing is, as soon as I get to this, I should be saying to myself, okay, well, 4 plus 2, or I should actually be saying, look inside the brackets, what can I simplify? I've got addition, I'm going to simplify that. 4 plus 2 is 6. Nothing happens with the exponents yet. Now all I have left is the exponents, and therefore I can rewrite this as 36. Now, alternatively, if you forgot BEDMAS for a few seconds, what does this exponent 2 actually mean? So if I just rewrite this again here, I can rewrite this as 4 plus 2 multiplied by 4 plus 2. Don't forget that this exponent is telling you that you're multiplying whatever is in the brackets twice, which is why we can rewrite it as bracket 4 plus 2 bracket multiplied by bracket 4 plus 2. And this again is going to simplify. Inside the brackets here, this becomes 6. My other brackets is 6, and therefore I get 36. Again, both ways worked. BEDMAS was much easier and a lot less writing. Alright, so talking about exponents, we have the zero exponent, and we also have one exponent. So we have to think about this. I'm going to show you a little bit of a pattern here. So what I've done is I've written the expanded version here, and I've written the index version here. Now, if I'm just simply looking at the right-hand side here, okay? So if I use that, it's all I'm saying is right-hand side. So if I look at the right-hand side, to get from 2 to the power of 5 to 2 to the power of 4, notice that I'm just decreasing my exponent by 1. And if I want to go from 2 to the power of 4 to 2 to the power of 3, again, I'm decreasing by 1. If I'm going from 2 to the power of 3 to 2 to the power of 2, again, I'm decreasing my exponent by 1. And that's going to come in handy in a minute. So I just want you to see that if I'm going down these ones, I'm decreasing my exponent by 1. Now, on the left-hand side, so for left-hand side, kind of like the right-hand side, I'm just going to call this the LHS for left-hand side. If I'm going from, oops, that was supposed to be green. If I'm going from the top one to the second to the top one, notice that I would divide by 2. So the top one was 2 times 2 multiplied by 2 multiplied by 2. Oh, there's 5 of them. There we go. If I'm trying to get from, maybe I'll give this one a different color, from the green one to the yellow one, then I would have to divide the green one by 2. I would reduce this. Remember, 2 divided by 2 is 1. And all I'm left with is 2 to the power of 4. So the important part here is that if I'm going from the green one to the yellow one on the left-hand side, I'm dividing by 2. And again, if I'm going from the yellow one to the blue one, alright, to get from 2 multiplied by 2 multiplied by 2 multiplied by 2, which is the yellow one, if I divide by 2, notice how this simplifies here, and I'm left with the blue one, which looks a little green now, but it is supposed to be blue. So again, all I'm doing is I'm dividing by 2. To get to the next one, again, I'm dividing by 2. So if I wanted to get to the next one, which is kind of hidden, they're down here. So if I'm going from 2 times 2 to 2, notice again I'm going to divide by 2. And notice again, to get to the next one, from 2 to the next one, I'm going to divide by 2. So 2 divided by 2 is equal to 1. And what do you guys think the next one would be? So I'm going to keep doing the pattern. So I'm going to divide by 2. So the last one was 1. I'm going to divide by 2. So I end up with a half. Again, I'm going to divide by 2. So I have a half divided by 2. Oh, we have to remember fraction rules. A half. And we multiply and take the reciprocal. So if you don't remember, I like to put this over 1. So now I can reciprocate, and I get 1/4. So over here we got a half, and we got a fourth. And if you're kind of questioning this a little bit, we're going to do a lot more detail on this in a few lessons, but I just wanted to kind of foreshadow it and bring it in now. And then the same thing with our right-hand side. So up here, remember we were going decreasing by 1, decreasing by 1, decreasing by 1. Oh, that should have been from here to here. And so from 2 to 2 to the next one, I'm going to end up with 2 to the 1. That makes sense, right? Because 2 is equal to 2 to the power of 1. Now, if I'm going down again, I'm going to decrease this again. Decrease my exponent by 1. So that means that this would be 2 to the power of 0. Okay, now this is really important. Okay, 2 to the power of 0 is equal to 1. And I know that you guys have always heard everything to the power of 0 is equal to 1. And this is kind of one of the little steps behind it. So anything with an exponent 0 equals 1. Alright, I'm going to keep going. I'm going to keep doing this. So if I decrease my exponent by 1 again, I get 2, and I'm going 0 minus 1. It's minus 1. I'm going to decrease my exponent by 1 again, so I get 2 to the negative 2. And these are kind of interesting, and these are what we're going to talk to you on the last lesson of this topic or of this unit. So if you're struggling with that one a little bit, that's okay. You do just have to kind of know what the powers are. And also really important, anything with the exponent 0 is always going to be 1. Alright, I think I have 4 last really quick examples. A plus b to the power of 0. Now, don't forget, this 0, it's touching that bracket, and therefore everything inside there is going to be affected. Anything inside there. If I put numbers in there, it wouldn't change. So this is going to be 1. And if I look at it in a little side example here, if I let a equal 5 and b equal 2, okay, we had a plus b to the exponent 0, or to the power of 0. Then I have 5 plus 2 to the 0. Well, BEDMAS says that 5 plus 2, that's 7 to the power of 0. Anything to the 0 is 1. Alright, next one. I've got b, it says a plus b to the exponent, or to the power of 0 here. So a plus b to the power of 0. Nothing's happening to the a, but anything to the power of 0 is 1. Alright, next one. We've got the exponent here is 0. My base, which is inside of this bracket here, is negative a. It's touching the bracket. Therefore, everything inside that bracket is being affected. Therefore, this is 1. Now, D is a little bit different. I have A, and that's not an X. It's supposed to be a multiplication symbol. A multiplied by B to the power of 0. Notice that the exponent 0 is affecting only the B. And therefore, what we end up with is A multiplied by 1, which is just A. And we're done.